Hi everyone. Now we are looking at another LeetCode question. This is 295. Find median from data string. The median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value. And the median is the mean of two middle values. For example, for array 2, 3, 4, the median is 3. For example, for array 2, 3, the median is 2.5. Implement the median finder class. Median finder initialize the median finder object. While addNum integer adds the integer num from the data stream to the data structure. Double find median returns the median of all elements so far. Answer within 10 to the power of minus 5 of the actual answer will be accepted. Input median finder addNum median find median addNum find median. So now 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 1.5 now 2. Okay, so I think the question is very clear here. It is stated that we want to find the median given a list, but we also know that the item will be continuously added, and we are also inquired on the find median at any point of the insertion. Alright, so I have read the question and I would like to ask a few questions. May I assume that find median will be called when there is an item added into the list or size of n. So there will be at least one element that's before calling median. Okay, at least one before calling median. And how about the size of n? At most 5 times 10 to the power of core, we will get to addNum and find median. Okay, so that will be at most 5 times 10 to the power of 4. Okay, follow up. If all integer numbers from the string are in the range 0 to 10 to 100, how would you optimize your solution? So if it is between 0 and 100, then I would say okay, let's go to that later, but let's just focus on the current problem in hand. So in here, I actually have seen this problem quite often, and the trick here is that we can use heap queue and add into heap queue. So here the hit queue will be the max. How would I say? I think it's called max hit queue or something like that. So let's just call it max hit queue. And then move half to min hit queue. Okay. So in this way, we end up with two different queue, except that one is sorted. One hit queue would return the minimum value, the one would return the maximum value. So the way to find the median is median is if size of max q is more than min q, or shall I write it in a better form? If the size of min q less than size of max q, so this is case 1, then return let's see max q dot top. Otherwise, size of min q is the same as max q. And here we return the median of the min q top and max q top. Top max q top of square. I mean half of them. Alright. So I think this is pretty straightforward. But I need to check how we are gonna use hit queue. Alright, so I think there are a few API that we can use here. So let's just move. I think. Okay, so how about we look at the examples then? So there are only one example, which is called add 1, and then we add 2, and median would be 1.5, add 3, and then median at this point it would be 2. So what we can do is that we can maintain two different queues. How about I'm going to check how many elements is in the queue. I can hit queue size. Okay, so just use a length. Okay, so what we can do here in the init, okay. So if we add to the min queue and max queue, so we have min and then max. Sorry, max and then min. So in the max, we enter 1 and then we enter 2. So 2, 1. But now there is more element in the 2, in the max. So we extract 1 and then put it into min. And then we add 3. So now we have max 3. And this 2. Hold on. Just notice an issue. So in here, the 3 should be inserted into the right one. Yeah. Okay, so our step is wrong then. What we need to do is so step 1, step 1 is we insert into 1 max queue if it is less than or equal to the top. Item less than equal to max q of 0, then this is max q. Otherwise, if item otherwise it is min q, and then we stabilize if length div by more than 1. Okay, so in that example, what we would do is that we would have 1 and then we would have 2 and 3. Okay, cool. So I think this should work. Now I would like to start implementing unless there is a further optimization that you want to explore. think they sound reasonable. Now let's move on to the implementation. First of all, we have the init. Here, I'm gonna call the max queue and then min queue. I think Python cannot create a min queue. Queue. Okay, so the solution is we need to negate something. But anyway, now let's create the heap new. Okay, so max queue and min queue are initialized to empty list. And then add num. Add num, what we're gonna do here is that okay, let's check. So if min queue and max queue so is max queue and max q and let's see num less than or equals to max q of 0, then heap q dot heap push to max q num, else heap q dot heap push Okay, I think another thing that we can do directly here is that after we push it, we need to check the size. If length of max q and if length of min q is less than or is it have to be less than if this size okay, so if length of min q plus 1 is still less than length of max q, then what you're gonna do is that heap q dot heap push to min q. What we are gonna input is that heap q heap port from max q, right? So if the size of max q is more than the min q plus 1, then we extract one value, one item from it, and then move it into the min q. And so the same we do for the if we insert for the min q part. Now let's move on to the find median. Okay, in find median, we need to check if length of min q is the same as length of max q. Then what you're gonna do is you return the top element divided by 2. Max q of 0 divided by 2. In here, I'm gonna assume that the API will work with min q. Of course, I am gonna handle the negation in our LeetCode. I'm just doing a simplification here for the sake of brevity. Else, let length of min q is less than length of max q, then we return the max q 0. Else, we return the min q of 0. Yep. Alright, let me just okay, let's handle the positive and negative right in here. So if we push it to min q, we need to negate it, and then if it is max q, then we don't need to do anything. Wait, it is min q, max q. Okay, so max q has to be negated, sorry. I think now this is okay. Mm. Now let me go to the code again to make sure I don't miss anything. In the init, I'm gonna create two array. One is max queue, one is for the min queue. In the add num, I'm gonna check if the max queue belongs to the I'm gonna check if max queue so actually I made a mistake. I should have checked for the min queue instead. So we check whether anyway, let me do it in the LeetCode later. So if the num belongs to max queue, then we insert to max queue. Otherwise we insert to min queue. Then later on, if the size is different by more than one, then we need to extract one element from the larger one and then insert into the smaller disk. Then the median, if we check whether the size are the same, if it is the same, we basically take both elements and then return the minimum, I mean the median of it, which is half of the sum of them. Otherwise, you just return one of the value from min or max. Okay, let me implement this right now. So first of all, we have min q and max q. There are empty lists at the beginning. Then at num, I'm gonna check if min q and min q 0 is less than or equals to num. Then I'm gonna hit q the hit push the num. Then I will check if length of max q, if max q plus 1 is still less than length of min q. Then what I'm gonna do is hit q the hit push max q. I'm gonna insert the negative of hit q. Actually, it's a bit confusing to do it this way. So let me just import them. From heap import hit q, hit push, and hit pop. Okay. So here I'm gonna insert to max q the hit pop from min q. Else hit push. To put in the min q there. Hit push the max q negative num, then if length min q plus 1 is less than length of next q, then I'm gonna hit this min q negative hit pop next q. Alright, now the find median, we need to check the length. Length of min q, let's check next q first, equals to length of min q, then we return the half of them, next q at 0 plus min q at 0 divided by 2, and this length of next q is the length of min q, then return min q at 0 else return the next q at 0. Okay, let's try to run this. Hopefully we got it right, but not the case. Hit q min q. Did you mean min q? No. The min q is not defined. Alright, so min q should be replaced by self dot min q. Change all. Next q are the same. Change up. So try to run it this time. Is this not right? Okay, so the max should be negative, and here the max also need to be negative. Alright, we got it right, so let's try to submit it. And yes, we got it correct. Okay, memory is good. Time is, I guess it's good, but let's try to look at a more efficient one. I think this is the same as what we did here. Yeah. Okay. Okay, so I think everyone is doing the same way. Okay, so now let's go back to the original questions, and there is a follow-up question there. Let's try to look into it. If all integer numbers from the string are in the range of 0 to 100, how would you optimize your solution? In that case, we know that the limit is from 0 to 100, so there are only like 100 possible values for the num, and in this case we can what we can do is that instead of creating the min queue and max queue and then store all of the values there, and we know that there are at most 5 times 10 to the power of 4, which is 50,000 items. If we put all of it into the list, that would waste 50,000 space, so that is on space. If we what I What I'm thinking is that we could do better by using a bucket of size 100. Yeah, so that would be give us the array of size 100, no matter uh, how many values that we add into the class. In this case, it will be an O1 size because the bucket size is fixed to 100. And then to find the median, we repeatedly from left to right, we count, we kind of use a two pointer, and one is moving rightward and then one is moving leftward. And then as this pointer are moving, we keep increasing the count, and we try to keep count so that the the number of element recorded by left and right pointer are roughly the same. If it is not, then we move forward the pointer with the lesser count, so that in the end, when it meets in the middle, we can find out what the median is. Okay, so I think that would give us an O1 space and O1 time, because in the find median, we just need to go through the bucket of size 100, which is fixed, and the add-on is very simple. We just increase the count of the number at the item, at the index item number. Okay, now we know that. So a second follow-up question: if 99% of all integer number from the string are in the range 0 to 100, how would you optimize your solution? All right, great. If 99% of all integer number from the string, so there is a 1% of the number that are outside of this range. Let's see. Well, in this case, I think we can just create an one additional bucket at both ends. So one bucket to store all the values that are less than 0, and then another bucket to store all the elements that are more than 100. It is slightly complicated, but in the end, I think this is just the space would be O1, but the time complexity, if is if the add num would be just also O1, because we just add one more bucket and the bucket size is fixed, so that will give us like 100 bucket plus two arbitrary, two buckets for all the small values, and then one bucket for all the very large values. And then the find median, it is, we can do the same thing as what we did, except that if the median is in the one of these additional bucket, then we need to do further processing. Right. So I think one way is just we just sort it, because there's only like 1% that are in this bucket. So if I take 1% of 50,000, then that gives us like 500 items in this bucket. So if we have like 500 items, we could just sort all these values in the bucket, and then we just count it like usual. And then we try to come up with the index where the median lies in, and just use this sorted integer array to find the median as usual. Okay. And is there any more? Um, hmm. I could also think of another solution for this. Like, hmm, yeah, sorry, I can't. I think a more simple implementation is would be we use a sorted dictionary at the beginning and after the range of 0 to 100. So outside of this, we are gonna use a dictionary, and so the find median would be more or less doing the same as we did before, which is using two pointer. Okay. I can't give a concrete solution because this is just a verbal discussion. But I think more or less the ideas would be somewhat like that. Okay, I'm gonna stop here. So thank you everyone.